There we go. So I just wanted to go over a few questions from the test. I guess just to mention, I put it on Canvas already, but the mean was 74. Standard deviation was 13.6. So everybody did about pretty good, at least considering the fact that we're like the first section. The average was C, so not too bad, all things considered. But there were a few questions that I guess most people missed, and I just wanted to go over those just so everybody's on the same page. Even though they might not show up again, they might be useful for you to have just in general. Plus, if you have any questions as well that maybe you specifically got and then I didn't really give a full explanation for all of the questions that you got wrong just because I would be grading for a really long time. So if there was any that maybe I didn't give a very clear answer on, or just you wanted to know the answer, feel free to ask it in the chat too. But anyways, so the first one here was given this declaration, integer pointer, and then we assign the pointer a new integer array of size 20. So this dynamically allocates an array of 20 components, and they're all integers. In terms of the array and its element, what address is located in pointer? So this one was a little ambiguous, a little open, but we should still be able to figure it out. So what this does, right, so there's an integer pointer, which just holds an address. That's all a pointer does. Pointer equals new integer, 20. So this part here, the new integer 20, that allocates 20 integers in memory, right? So that allocates 80 bytes, 4 bytes per integer, and so we get something like this. ... And as far as the indices go, this would be 0, 1, 2, 3, 4, ... 17, 18, and 19, which is 20 minus 1, because we start counting at 0. All right, so if we consider what this does, so this line itself, that allocates the 20 blocks of integers. And whenever you do a allocation using new, it always returns the pointer to which this memory block was allocated at. So pointer here, this thing is going to return the very, very top of our array allocation. And so if you do that with a class, it'll allocate it at the top of the class. If you do it with an integer, it'll allocate the top, or return the pointer to the top of the integer, which I guess is kind of standard because things like integers and characters and booleans, those are just one single block of bytes, right? So it kind of makes sense that it would do that there. So pointer is pointing to this. So then, and I know I went over this with some people, but I'm not sure who really got this question on their test. So I guess another thing to consider here is that not everybody got this question. In fact, it only looks like 5 people got it. So in terms of this pointer, what else is that pointing to? Is there anything that shares in common with? And I mentioned this in the Discord a few times. But when you allocate an array pointer, it's technically valid in C++ to actually use it like it's an element, which doesn't make a whole lot of sense in terms of what we're doing because it's an array. So if you were to dereference it or do something, so this is what that magic function did, which is why some people were getting bugs at first, is if I was to see out dereference pointer, that's actually totally valid. And what that does, if we consider what dereferencing does, it goes to that pointer location, which is right here. And then since this is an integer pointer, it's going to go and interpret it as an integer. And an integer is just one of these blocks of integers. So in this case, dereferencing a pointer, the pointer to an array, is the same thing as going to the 0th element of that array. So when it says what address is located in pointer, it's in that case, it would be the address of the beginning of the array. Which kind of makes sense if we think about it, right? Because this right here, that's that's pointer 0. It points to the beginning of that integer, right? Which is the same place that this is pointing to. So whenever you have an array pointer, it's always going to point to the beginning. So just felt like I would mention that. I know a few people asked about it on assignment 5. So I guess I've put some sort of diagram in the chat before. And I think we talked about it briefly during class, but that was just something to bring up. And if you have questions on any of these, feel free to stop me at any point. I'm just going to keep going through them, I guess. So this one turned out to be a bit hard, and I guess I kind of expected it to be. So this is one of the few questions I think that we're going over that I actually wrote. And in this one was intentionally a little bit difficult. So given the following code, so in case it's hard to read, given the following code, which is just x.y, and assuming that this is valid, that x is some sort of class type, or struct, and that it has a member y. Without changing the fact that x is a class type and not a pointer, so this has to be an object, is there a way that we can redo this to use the arrow operator instead of the dot? So then the first thing we need to consider is, well, what can I use the arrow operator on? Does anybody have a guess as to that? What do you have to be able to use the arrow operator versus the dot operator? Right. I think you're on the right track. So we need a pointer, right? And I did accept if people wrote like integer pointer equals address of x and then wrote another line. That's totally fine. I took that as well. I did try to put here that it would be one line, but if you put that in your answers, I ended up taking it. So yeah, you're on the right track, and in fact, this is kind of the important part. You have there that the pointer would be equal to ampersand x, right? So this part gets me the pointer, right? And now I'm allowed to use arrow operators only on pointers. So I need to turn x into a pointer and then use that pointer to actually get the thing. So these are actually equivalent in what they do, and this one uses the arrow operator and a pointer, and this one uses the actual object. Why you would ever do this? No particular reason, but it's very important, I guess, to consider if you're going to be doing C++ programming, that when you use a pointer, you need, or an address, which is technically a pointer, you need to use that arrow operator. So most other languages just use the dot and there's no arrow at all and you don't have to make a distinction. But here it's kind of a thing just to make sure, I guess, you know you're using a pointer. And that one was a bit tough. I kind of did that intentionally. Okay, so next one we have, a lot of people end up getting this question, I noticed, because I ended up grading it a bunch of times. So we were given this code for a class called vehicle that has a name and then two constructors. So the default constructor, which just prints constructor 1, and then a constructor which takes a string in called n, sets it to be equal to the vehicle name. So this was the syntax that was in assignment 5 that I briefly mentioned, but I never use, so I don't ever write that when we're doing code in class because I'm not really a huge fan of it. But that sets vehicle name equal to n, and then it prints constructor 2. So we want to derive a new class sports car that inherits publicly from vehicle. So I think most people got that part, right? So that shouldn't be too bad, right? We just declare a class called sports car. I'm going to have to do 2 lines here. And then we inherit publicly, so we put public and then the name of the class that we're inheriting from, right? So I think most people got that. Inheritance we just do with a colon. And then, that's a terrible curly brace, but we're just going to deal with it. And then this is the part that I think tripped a lot of people up, which is define the constructor for sports car so that it only calls vehicle constructor 2. So we need to call this one. And I think what tripped most people up was they tried to emulate this part right here with the vehicle name, but that only constructs the vehicle name. We want to call the vehicle constructor. So that would be, if I was to define this, so let's just put public here just so that the constructor is consistently public. So in order to do the constructor for sports car, I need to put sports car. So this is the declaration of the actual sports car constructor. And then the argument list, which I guess would have to be a string. And the reason we need it to be a string, or perhaps it's better if I write this over here. Let me write this so we have more space. Sports car. So the reason I'm going to give it a string parameter is because it needs to call constructor 2, which also takes a string parameter. So at bare minimum, we need another string. I'll just call it n again, but we could have more more parameters as well, and it would be totally fine. But we need at least a string. Or we could also provide it a string. So similar to what you did in assignment 3, where maybe when you wanted to call the player class base class from red or green or blue, you would have given it the name red or green or blue directly rather than pass a parameter, which is totally fine if you expect it to be a constant like that. So we have sports car here, and then it's going to, so in this case we want it to call constructor 2. That's a vehicle constructor. So we need to explicitly call vehicle n. And so that's what would have gotten it there. So if you put vehicle name n, it's actually going to construct vehicle name, which is a string, to be n. So strings, it might not seem like it, they actually have constructors as well. But when we do this here, it's actually going to call the vehicle constructor, and that's the one we want. The vehicle constructor right here is the one that prints constructor 2. So that would have been what we need for that one. Again, if you have any questions on these, feel free to stop me. Oops. Alright, so we got this one. I guess I don't really need to write anything for this one. It's just a true or false. Or sorry, multiple choice. So which of the following statements are true? The delete and delete operators, delete with the brackets, statements can only be used in a destructor, and it seems like everybody got that right. So yeah, you can use those anywhere. We could use those. In fact, what you should have done in assignment 5 was use those in build function to avoid memory leaks. If you were going to upgrade over a gadget, you should delete the old one before you put a new one into the array. So operators aren't particularly restricted, and I think everybody understood that. So most people got this part. So this was the only true statement out of these 3. So this one was, when the destructor of a derived class executes, the destructor of the base class is automatically invoked. Same thing goes for constructors. Whenever you call a destructor or a constructor, whether you want to or not, C++ requires you to call a destructor or a constructor of the base class, which is a little bit strange. I'm not a huge fan of that behavior, honestly, but we've gone over that a few times, I suppose, and a lot of people ended up asking about it in the Discord, because I think a lot of people were getting compiler errors, and you maybe get unintended side effects if you're not aware of that. And I do still think it's a little strange that it actually requires that. I think it's a bit annoying. But anyways, I digress. So most people got that. And then it seems like a lot of people, or 100% of people, got tripped up by this last one. So this one's not true. And maybe it was just the wording. But in a single inheritance, a base class can be a base class for only one derived class. So let me do a counter example to that. So in the game object example we kept doing in class, I said it was fine for maybe a player to be a game object and an enemy to be a game object. If I could spell it right. And then boom. That was totally fine, right? That was valid C++ and valid inheritance. And it's a good thing that it is, because now we can inherit a bunch of different things from the game object. So we can make a bunch of different instances that are game objects, but do something specific. So in a single inheritance, a base class can be the base class for only one derived class. Not true, because I just have 2 right here, and that's totally fine. And I could definitely have more, right? So there's no cap to the amount of derived classes that you can make. Maybe it was just the wording on that one. I was just a little surprised. I actually asked a similar question to this, but I don't think anybody got it. As in, like, I don't think anybody was given it in the test. Or asked how many times are you allowed to do inheritance. And the answer is infinitely many. There's no cap to it. This one, I might actually just skip. Now we'll take a quick look at it. So we have this code here. Maybe it would help if I zoomed in a little bit. It is kind of small. So here's some code that's written. And so we have a class animal, and then we have 3 fill in the blanks, which are for the modifiers. So public, private, and protected. And because this is a JPEG, it doesn't let me actually click on these. So we have an ID and a name, a virtual abstract function, or a pure virtual, if you will, function called make noise, and then the constructors and a function called pet for the animal. And then we have 2 derived classes, a cat, which implements make noise because it was abstract, and then it has a constructor, and then a class called dog that also inherits, and then it makes noise and does woof. And then we have, I decided not to do a static variable just to maybe make it easier for you to understand when reading this, that we have an animal count that just counts them. And all that does is it initializes this ID. Oh, did I forget to finish writing that? Oh no. Oh no, I didn't. This is fine. So there's a constructor here that just takes the ID for cat and dog. So here we call cat with the animal count, which is 0, so that sets its ID, and then does the animal constructor, which takes the ID and then it gives it the name cat. And the dog does a similar thing. So the real question here was what modifiers would work best for this. So the reason I was going down to this is if we consider, I'm calling this constructor right here, right? So if I'm able to call this cat constructor, which is public, then the constructor up here needs to be at bare minimum protected. And if anything, it would probably make the most sense to make this one public. And the reason being is we probably want to be able to construct an animal in main. And on top of that, this constructor here is public as well. That's calling that one above. So it would probably make sense to make all of the constructors public. On top of that, we do have this function pet, which is called for main. So this, I guess, was the main determining factor. We have this function called pet, which is called in main, and that's only possible to call outside of the scope of a class if it's public, right? So public variables are able to be used anywhere. Or public members, I guess, would be a better way to phrase that. So whether that be a function or a variable. So this section for sure has to be public because pet is called in main. On top of that, it also makes a bit of sense to make animal public. So this one's public. This one here, if we look at it, so I think there's some, I must have cut it off, but it said somewhere that you're only supposed to use each modifier once. So if this one's public, then one of these has to be protected, one of these has to be private. And you may notice that here we have ID and name, and this ID and name are only ever used right here, which is within the animal class. Never used it down here. This is a completely different ID, right, because it's the parameter one. And then on top of that, make noise is abstract. And if it's abstract, that means that we have to be able to write it in the derived classes. So the derived classes have to have some sort of access to it. So right here, it appears I make it private, but I don't think anybody actually ended up missing that one in that regard, or putting private for this one. So if we're going to use it in the base classes, it probably makes sense to make it protected because that's the modifier that means that you're allowed to use it in any classes that are derived from this one. And then I think ID and name would make the most sense to be private because ID and name are only used, or this ID and this name rather, are only used here. The rest of them are all parameters, right? This ID and that ID are those two. And then same thing down here. these two IDs are parameters, so they're not actually the ones from the class. A few people got this one right. I think in general, a lot of people got the private right, and then maybe just got the protected and public switched. And that one was a little bit open-ended. The main thing, I guess, was that you hopefully got that this was public. That one absolutely had to be public. The other two, I guess, technically would have compiled the other way around, but it would have been a little bit strange to do it that way, I think, given our implementation. Okay, so if you have any questions on that, let me know. Next one, just got a few more, try to breeze through them. Oh, this one's super quick. So here we have this one, which was at the very end of the test. So everybody got this one. At least like everybody received it. So we have three functions, all with the name print number. So they're all overloaded here, right? So we have a version that takes a string, a version that takes integer x, and a version that takes a float and a boolean. And so if we want to print the number I got was 17.4, then hopefully it's clear we can't call this one because it takes an integer. So if we try to put in 17.4, that's not going to work. It's not going to be able to call the middle one. So that's out of the question. And then so we're left with here and here. So I could just say 17.4 as a string, so I could do something like this, which I don't think I actually received any answers like that. And then that would say the number I got was 17.4, but it would say as a string. Right, so that one doesn't actually work either because it's going to print that extra stuff. So for sure, we have to call this function. So in order to call that one, we have to be careful here. So I was a little bit tricky about this. It takes a float, which is obviously 17.4 because that's what it prints. So the number I got was 17.4, but it also takes a boolean. So you could either put true or false here and it would be totally fine. So in order to overload a function, remember you have to give it these parameters that match. So here I had to give it a float and a boolean. And I can't just use the variables themselves because this is not like within the function itself, right? We're calling it. So I actually have to give it values. So if you put either 17.4 true or 17.4 false, those would both be correct. This one I think I only briefly discussed in class, so I guess it's a little understandable if this one was a bit hard. So on pointers, you can do the following operations, and so the correct answer here is add, subtract, increment, and decrement. So the only difference I think between this one and that one, so this one had add and subtract, which I'm pretty sure the sample code I put on Canvas has add and subtract in it. If not, I'm pretty sure I did it somewhere and maybe deleted it. I don't know. But yes, we can add and subtract pointers. We could say something like pointer plus equals 10. And that's totally fine. So depending on what the type of this is, this will advance 10 types into the future. Or like down in memory. So if I had like an integer pointer called pointer, this would skip 10 integers down in memory. So 40 bytes. So we do have the ability to add, subtract. You don't have the ability to assign a positive integer. So I can't just say pointer equals 10. That's not valid. And part of that is that so that's actually a good thing, I think, that we can't do that, because that means that we can't just say go to this memory location that's completely arbitrary, because again, when we're assigning memory, it's completely random. Or at least random as far as we're concerned. So when it allocates memory, we don't want to just make a guess as to a hard fixed address, because we don't really know that that's going to be correct. So just consider maybe one time when I run a program, it might allocate the memory here, but the next time I run it, it might allocate here. So it's not very beneficial for us to be able to have that assignment of a constant address as an integer. Plus, there's some things that the system does that might actually prevent that as well. But I won't talk about that. So there's something to keep in mind. You can add, subtract pointers. I know we didn't do a whole lot of that, so I guess that is fair, but that is, I guess, a thing that exists. So let's see. Oh, right. So this one. So we have this code here. So we have a class called example, and it has two private variables, x, and a static variable called count. And then we have a function called test function. So at the point with the comment, so at this point in test function, we have to ask what variables are usable. So we have three variables here. We have name, count, and x. So let's start from the bottom. If I was right here in the code, would name be usable? I think everybody got this part. Yes, yeah, you got it right. So yep, that one definitely can be because it's a parameter to the function, so it would make sense that I'm able to use it in the function. Now let's consider this function is static. So what about count? Count is also static. Does that mean I can use it? Or is there something special about that? Yes, question mark, fair enough. You are still right. Yes. Yeah, we can use that one. So static variables can be used in the context of a class, can be used in any scope. Because if you remember, a static variable, or a static member, rather, is just one that doesn't belong to any specific class. Or sorry, any specific instance of a class. So that means it's just kind of free-floating. It's almost like a global, if you will. It's a global that belongs only to that class. So static count, totally usable. It's usable whether this is static or not, it is usable. So even if I didn't put this here, we still would be able to use count. Now then comes the question of x. Is x usable here? And so for this one, maybe we still want to use that kind of global comparison. So if this function is at global scope, this one's at an instance scope, would I be able to use it? And the question, or the answer to that is no. And I do remember there is some diagram on the Canvas page that I drew. I'm not sure if I'd be able to find it because it's probably super buried in there. This might be it. Let me see if I can find it. Right, so I had something like this that we drew in class. So remember that these arrows are only able to go this way. So things in the static scope are able to be seen by everybody, but static variables are not able to see instance variables. Because instances are just like individual people, right? So if I was to go with the global scope and just ask, what's x? Or in this case, let's just say for this example with the game object and the player and the enemy, I say, get the ID. Well, what does that mean? Does it mean to get the ID of the player? The enemy? If I had an item, does it mean to get the ID of the item? It's not really possible to figure out what that means if we have a bunch of instances, right? So asking for an instance variable, like ID, or the print character, or something like that, in a static scope doesn't really make a whole lot of sense because we don't know which instance it's coming from. But you're able to figure that out when you're in an instance because you have this keyword, right? That tells you which object called the function. Now we don't have that advantage when we call a static function because a static function doesn't belong to any specific instance. So that's why we're not able to call x here, or use x in this case. So I guess the takeaway here, if we want to keep it simple, static variable, you can use anywhere inside that class. potentially outside too if it's public. At that point, it's really just almost a global. A instance variable cannot be used in a static scope. So we cannot use this statically. And again, that's just because we can't really know what instance we're talking about unless we have an instance to talk about. So if you have any questions on that one, again, feel free to ask in the chat. I think we're almost all the way through these. I think there's like one or two more. Oh, there's only one more. Good. Okay, cool. And that's pretty simple, I guess, as far as, ooh, it's bad aspect ratio. Good enough. It's kind of stretched, but pretend I scaled it correctly. So what is the difference between syntax and semantic errors? And I know we only briefly went over this because I kind of had to shoehorn it in at the end of the review, but I think most people got partial credit on this one, but a lot of people got the semantics error incorrect. And so the answer I saw a lot, and maybe I just misspoke, I'm not sure, I didn't actually go back and watch the recording, was that semantic errors always compile, and that's not true. So I think everybody, or most people at least, understood the syntax part. So syntax, that's the form or structure of a language, and semantics is the meaning. So in some cases, we might actually have something that doesn't compile with semantics, and then I guess what I mentioned was that it's somewhat subjective in some cases. So there's semantics as far as the compiler is concerned, and then there's semantics as far as a human is concerned. So I think everybody, or pretty much everybody, got the syntax part right, which was just, if I had maybe like a for statement, then it has to look like this, where there's some expression in between these and then semicolons. So if I did something like, for, and then just ended it there, then that's not syntactically correct because it doesn't have the semicolon, so it doesn't have the correct form or structure of a for loop. It doesn't have like the semicolons and the statements that are on the inside. Now, semantics errors, it's totally possible that we could get some that don't compile. And the example that I think I gave when I was leaving comments for people was something like this. So let's say I have a class called person. What it contains isn't necessarily important, but let's say I try to do this. So the first question is this valid? And the second question would be, is the compiler going to actually tell you that this is a bad thing? So first off, is this valid semantically, or is it a semantics error? So it's invalid, right? At least from a human standpoint, for sure. It doesn't really make sense to set a person equal to 4, because 1's a number, and 1 is a class. Now, is the compiler going to catch this, or is it going to compile and let you do this, and then at runtime, is it going to tell you that it's a problem, or you're going to get a bug, or something like that? And so if I was to throw this in on a compiler, you should notice that it will say something like type mismatch. I'm not really sure what the compiler on Sally will say, but this will catch it. That's a compiler error. So when you try to do something between types that don't actually match correctly, that is an example of a semantics error that the compiler is able to catch. And this is a semantics error rather than a syntax error because this is still valid in terms of its structure. Because here, whenever we use an equal statement or an assignment statement, the left side just needs to be a variable with a potential declaration that's allowed, right? And then the right side needs to be some sort of expression, which for technically is. So this is still syntactically valid. And I did notice at least a lot of people put, which was correct, that in order to have a semantics error, you need to be syntactically correct. Because if you haven't even formed something, then you can't really derive any meaning from it, right? But the meaning of this is not correct, and it's also not correct as far as the compiler is concerned, because you're assigning types that don't make sense to each other. So that's totally a viable thing that could happen. So I guess just for future, I will probably stop it here. I'll let you reflect on it a little bit, and if you have questions on it, let me know. I know Dr. Pedersen usually talks about it quite a bit in his classes on like programming languages and compilers and all that. But there's really 3 types of semantics errors here. So there's static semantics errors, or ones that can be checked statically. So that would be something like this. So the compiler will catch that. There's dynamic semantic errors, which are semantic errors that won't be caught until runtime. Now these are not very common, but I guess I can give you one example that's pretty simple. So these are ones that are caught not by the compiler, but rather while the program itself is running. So these are caught at runtime. And so a common example of this would be int x equals 4 divided by 0. Now the compiler might actually catch this because you're explicitly using the word 0, but maybe if I did something like this where I said int y equals 0, and then I said that x is equal to, maybe let's just make this a little bit easier to read, x is equal to 7 divided by y. This is not semantically valid because we're doing division by 0, which is going to throw an exception, hopefully. Maybe it'll convert it to infinity. It depends on the compiler, I suppose, but some compilers will tell you that this is not something you're allowed to do. Or I guess rather, the compiler won't tell you, but the runtime environment generated will actually tell you that this is invalid, which it should be, right? Because 7 divided by 0 that's undefined in math. Like, and I know some runtime environments will set that to infinity, but that's undefined behavior, or an undefined value. So that is an error. But this is totally valid in terms of the semantics and the syntax as far as the compiler is concerned. It can't check it while it's compiling. It would have to check at runtime because it might not necessarily know what y is unless it does some sort of complex calculation and actually runs the program to figure out what y is equal to at this specific line. So it would actually need to execute these 2 lines of codes to figure out that y is equal to 0. It's not able to just look up here and say, oh, yeah, it was 0, because it doesn't have any like explicit value. So this would compile, but it would give you an error when you ran it, which is a semantics error from both like a human standpoint and as far as the computer is concerned, because it can't do that. So that would be an example of a dynamic semantics error. And then we have, I guess, the last one, which I would say would just be a human semantics error. I think this was the point of confusion. So I think a lot of people just thought maybe this was the last one, because I think I focused on that, maybe that a little bit too much when we were talking about it. But this would just be bugs. So these are just semantics errors as far as like your personal interpretation. The program is not working the way you want it to work. So it'd be just like, it prints out the wrong input or something. Or sorry, wrong output. And again, you'll talk more about these if you are a CS major. You'll talk more about these when you take a programming languages or a compiler class. But maybe it's just good to know that these 3 are kind of like the categories that we can split these into. Bottom line, I guess, to take away from this is that semantics errors can possibly compile, and they can possibly not. Depends on the context. All right. Any other questions on anything that we've gone over, or any other questions that you wanted to go over on the test before we do a little operator overloading? People might be typing. If you are, feel free to finish whatever you're typing. In the meantime, I guess I'll pull open the Visual Studio thing. Alright, so let's do a little bit of review, because it has been, I think, 2 weeks since we last talked about this. So what we were aiming to do here was create some sort of fraction class that was able to basically have a numerator and a denominator. So we have this declaration somewhere. So we had a fraction.h interface file here, the header. And we had a class that had a numerator and a denominator. And we were just hoping to make it work like normal math, where we could do addition, subtraction, multiplication, and division with the fractions. So we had defined addition previously, or sorry, multiplication, because it was kind of easy. And we'll do addition now because I wrote some code to help with that. But I guess what we were doing previously is we were saying we want to be able to write these like we would any other normal mathematical expression, where we just use like a times operator or a division operator or whatever. So the way we were able to do that was with operator overloading. So you'll see here it allows me to do fraction 1 times fraction 2. But if I remove all of the code that we wrote last time, then it should give me an error. Oops. Right, so it'll say something like operand types are int and fraction. So there's no operator times that matches these things. And so I guess if we think about what that means, it's that, what does it mean to multiply a fraction times a fraction? Or, oh, apparently, comment enclosed after. I don't know what's doing that. Oh well. This should give us an error too. But really, when we write stuff like this down, at first, it's kind of like, what does it mean to multiply a fraction by a fraction? And you maybe as a programmer have some sort of idea what you want that to mean. But the question is, like, how is the compiler really going to know what you mean by that? So a compiler doesn't know what a fraction class is, right? So how is it supposed to know what a fraction 1 times a fraction 2 is? And if I wrote class person, and let's just say it only has an age, and if I wrote person P1 and person P2, and then I try to make a third person P3 and set equal to P1 plus P2, what does it really mean to add two people together? Like, maybe from a programmer standpoint, that's still kind of unclear as to what that means, right? Fraction, maybe we have some sort of baseline understanding because it's mathematical, but the compiler really can't know that either, unless it's specifically written into the compiler. Maybe when we write person 1 plus person 2, we mean to add their ages. Or maybe if they had a string name, maybe we mean to like combine their names together. Or maybe we mean to create a new person and combine their age and their name together and do something else special, like maybe make them 10 years older or something. So it's kind of unclear as to what this behavior is, right? And so the compiler by default will tell you, well, I can't really do that operation. I can't do a plus or a times, or even something like this down here, where I try to see out the fraction. It doesn't really know what that means. So maybe we want the fraction to print out like the numerator over the denominator, or maybe we want the person to print out the name. But hopefully you're finding from doing the assignments, like assignment 5 or 4 or whatever, that you can't just say cout and then a class name, because you can't just print an object. It doesn't really know what that means. You usually have to do something like get name, right? You're typically wanting to print the name. But it's really not clear, just inherently, what that means to the compiler. Does it mean to print the name? Does it mean to print the age? You know, not really obvious. Does that make sense so far? Why it doesn't have all these pluses and prints and all that by default? Because it's kind of not really sure what to do with that fact unless you explicitly tell it what to do. So then what we did previously was we actually defined that multiplication to work in the way that we expect fractions to work. So we went here in the fraction class and we defined a operator. In fact, it only looks like I defined one. I guess I just didn't finish the rest of them. I suppose I'll have to do that. Okay. So what we did here is we defined a operator pretty much in the same way that you would define a function. So the way we define operators, so that we can actually do it, is basically the same way as a function. So you give any sort of modifiers that you want out in front. So I wanted this to be static because I didn't want it to work on any specific fraction. And then I put friend, which again we barely briefly went over, but really all that means is that it's able to access everything in this class, all the private variables, even though it's not actually a member of the class. So here I have a friend function, and then we give a return type. I guess just so that we have a parallel, something like this. If I was to write it normally, maybe it would look something like this. So friend static fraction multiply So if I was to write this multiply function the way that we're probably used to, I would do it something like this, right? Where I say modifier, so I want it to be a friend function, I want it to be static, I want it to return a fraction, and I want the name of it to be multiply. And then it takes two arguments, fraction 1 and fraction 2. In a similar vein, that's kind of how we define these operators. So we give it some sort of modifiers, we give it a return type, so when I multiply two fractions, I want it to return a fraction. And then we say, rather than the function name, so this is really the only difference between a normal function and an operator overload, is that we say operator, and then we give the name of the operator. So here, I want this function to be called times, or like star. So really, this is a function, it's just a function with a special name. So we have a function here just called operator star. So whenever I do fraction 1 times fraction 2, it will automatically call this function for me. And that's just nice to be able to read, right? It was our justification for this. So really, I could do anything with a function. This is just for the sake of, being nice to read. So I'll comment this out for now. So what we did previously was we went and we rewrote the actual function outside of the class, which we kind of have to do here because it was a friend function. And we said that when we multiply two fractions, so when I multiply fraction 1 and fraction 2, I just want it to work like normal fractions. So we'll create a new fraction where the new numerator is just the numerator of the first one times the numerator of the second one, and the denominator will be, let me rewrite this so it looks nicer, the denominator of fraction 1 times denominator of fraction 2. Right, so now we're able to say like fraction 1 times fraction 2, that's the thing. So let's try to go about finishing the rest of these operators. So let's try to do a plus, a minus. I'm going to delete this one, we'll come back to it, we'll rewrite it. And then we'll maybe do an insertion and an extraction and maybe an equal if it lets us do it. hoping that goes up in a second. There we go. Right, so let's say I have two fractions. So let's say fraction f1, and that has numerator a and denominator b, and then fraction f2, and that has numerator c and denominator d. So if I wanted to do ab, oops, let's write that out a little bit better. So if I wanted to do f1 divided by f2, let's consider how we do that. So if I have two fractions, a, b, and then divided by c, d, does anybody remember how we do this typically in math, at least like an easy way? Assuming these are integers, because that's what we have them as. Right, yep, you got it. So right, there was that whole thing, at least if you went to like grade school here in Nevada, there was that whole like keep, change, flip thing. So keep the first one, change the division to multiplication, and then we flip this to d over c. Right, so this is another way to, I guess I don't really need this semicolon. This is another way to do division, right? Just flip the second one and then multiply. So then we know that here the numerator is going to be equal to that, the denominator is going to be equal to that. And then once we're done, it's going to be something like AD over BC, right? So the output of this operation is going to be a fraction. And then we have this behavior here. So this is how we actually calculate it. Everybody clear on that? Mostly just a reminder of how it works and kind of how we ration through actually making these operators. Okay, so let's implement that really quick. So we just want to make a new fraction where the numerator is a times d, denominator is b times c. And then we'll consider some other stuff in a second. Right, so let's just go here first and let's define it. So if we're going to make an operator, let's make it a friend function again, which just means that it can access any private variables, which are just the numerator and denominator. We need to make it static. It's going to return a fraction because we know when we divide two fractions, it's going to give us another fraction. And we're going to do division. And when we divide, it will be between one fraction and another fraction. So then really quick, we'll write that here. So just to implement it, we don't need to put friend whenever we do it outside of a function, or sorry, outside of a class. So we'll just do the rest of the declaration. So static, going to return a fraction operator, divide, and we said it takes two fractions, f1 and f2. Okay, so let's write this maybe a little bit easier to read than these ones, but maybe a little less efficient. So we know that fraction, we'll just call it result, maybe, is going to be, it's going to be the numerator of the first one times the denominator of the second one. We said that's going to be the numerator now because we flip it, right? Flip the second fraction, so the denominator is on top. And then the second one is going to be the denominator times f2 dot numerator. So the numerator flips to the bottom, and then we'll just return result. Cool. So let's make sure that works really quick. So we have 4 over 5 and 3 over 7. So really quick, let's go here. And I don't think I wrote a print fraction function, did I? Oh, yes, I did. Okay, perfect. Yeah, so let's do that really quick. So let's say fraction 3 equals fraction 1 divided by fraction 2. And then we'll say fraction 3 dot print fraction. So let's remove this for now. Cool. So hopefully when we actually do this, we're doing 4/5 divided by 3/7. So we should get this flipped, which would be 28 over 15. Okay, so we run it. Hopefully my computer doesn't freeze. There we go. And that's what we get. We get 28 over 15. Sweet. So now division works the way we expect it to. We're able to write these fractions and just kind of write divide, and then it just works, which is just nice for reading. Okay, so let's throw in maybe a couple things here. So let's do one other example with these. So let's say instead of this scenario, maybe I want something else that a fraction can do. So maybe if I have fraction here, we'll just call f1 again, and let's say it's a over b, and then I do int x equals 4. And then I'll say fraction f2 is equal to f1 divided by 4. So in math, it's also okay to divide a fraction by an integer. So maybe we want that kind of behavior here. So in this case, we're doing ab divided by 4, right? So the way we do this, right, is just to keep change flip again. So this would be a over b, and then we know that any integer we can write as divided by 1. So this would be times 1 over 4. So if I was to more generically say that this equals, instead of 4, let's say this equals some constant c, then we know that if this is c, then we're going to multiply it by 1 over c, right? Everybody okay with that? It's really just a math review just to justify doing the computer science. So the reason I'm doing this is because I guess I'm trying to demonstrate that it doesn't necessarily always have to be the same fraction, or like the same parameters. So rather than divide fraction 1 and fraction 2, I could do something like this, where I take fraction 1 and I divide it by an integer called c. I don't know where that compiler error is coming from. Function, definition for operator. Oh, yes, we're going to write it. Right, so I can go down here and let's delete this. I don't need it anymore. So we were saying if we were dividing a fraction by some number, some constant, then we could do something similar where we say fraction result, and then that would be the numerator of the first one times 1, which just means it's going to be just the numerator, and then the denominator is going to be f1 dot denominator, and then times c. Right, that's kind of what we said here, right? It would be a times 1, which is just a, and b times c, where b was the denominator. Cool, and then we need to make sure we return that. So now we might be able to do something here, like say fraction f4, we'll just say f4 for now, is equal to fraction 1 divided by 7. And so what we should get here is 4 over 35, right? So if I said f4 dot print, we should get 4/5, which is fraction 1 divided by 7, which is 4 over 35. And if we run it, that is indeed what we get. Cool. So now we've defined behavior for division that works with fractions in multiple different ways. So I guess the nice thing here, which is kind of like what we mentioned before with function overloading is I can overload an operator to have multiple different definitions. So here what I've said is that I can divide two fractions, or I could divide a fraction and a number. And then this is how it's done. If I want to divide two fractions, I need to multiply the numerator of the first by the denominator of the second, and the denominator of the first by the numerator of the second. And we could keep going. We could do a integer divided by a fraction and have that return as well. But I think we'll say that's good enough for division. Any questions on the syntax or how any of that works so far? I don't see any questions, so you'll do. You don't need to initialize int c in main. I don't actually have to because it's a parameter here. So these are really just functions with a special name. So when I use c, it is just the parameter function, or a parameter to this function, just like any other parameter. So its definition, or I guess declaration, is here. Its definition is whatever you call it with, right? Which in this case was 7. So just like when you call a normal function, it will go up to here and say, well, f1, that's fraction 1, that's the first argument, which is on the left side of the operator. And the c, that's the thing that's on the right side of the operator, so that's the second argument. Now, something important to consider about that, now that you mention it. What if I did this? Oops, int c. You'll notice it gives me an error, but why? Why can't I do this? I guess I won't scroll over that because it does give you the answer. Or for that matter, why can't I just say fraction, make that the division operator? Do you only have 2 parameters in your class function? Oh, yeah, that too. Okay, yeah, you're right. That's fair. Fair point. What if I delete it there? What if I make it 1 now? It should still not compile. But yeah, you're right, that is a problem. Sorry. Well, maybe something to consider is how do you normally use division in math or in programming? Am I allowed to do something like int x equals 5 divided? By the fact that there's a red underline, you could probably conclude that no, you can't. But I guess the takeaway here is when I'm doing division specifically, there's always only 2 things, or always 2 things. Can't have 1, can't have 3 or more, because when you do division, it's just one number divided by another, or one thing, I guess, divided by another thing. So this is what we would call a binary operator, because it takes 2 things. So the reason this isn't working when I put 1 or 3 is because division by definition requires 2 things in order to work. So I can't do it with 1, I can't do it with 3 or more. Not allowed. And so you'd notice also if I tried to do like times or plus or any of those, I am only going to be able to do it with 2 as well, because they're all binary operators. They all take 2 things. Likewise, if I was to try, I haven't written the declaration, but let's just say I was hypothetically trying to write this here, operator, and then I did plus plus, you could actually totally redefine that as well. So maybe add 1 to the fraction. This will only work if I have one fraction. If I put a second one, it'll give me the same error. Extra parameter of postfix operator plus plus. So it calls it a postfix operator, which is right. That is, I guess, the name of this here is a postfix because we write it afterwards. And the thing about that is that when I write plus plus, that only takes one thing. I can't say I plus plus j, right? That doesn't work. I have to have one thing with a plus plus. So when you do an operator overload, you need to preserve how many operands, or in other words, parameters to the function that you have, because they need to match how many the actual operator itself takes. Now there are exceptions to that depending on the language. So in some languages, if you put a minus, it will actually negate it, which C++ doesn't support, but you can do that in C# for sure. I don't think you could do it in Java. So you could potentially have one that takes one parameter and one that takes two parameters, depending on the context. I don't think you can do that with dereferencing, because that's one example of one in C++. Because I can do, I could do this if x was a pointer, and then I can also do, this. So I can use the star as a unary operator where it operates on one thing versus a binary operator where it operates on two things, depending on the context. And I don't think C++ lets you override this one because it's behavior that's defined for even classes, so I don't think it lets you do this one. I think it always assumes it's the two-parameter one. So just something to consider. You always have to match the parameter count. Otherwise, it's just straight up not going to work. So you can't redefine the way that the operator itself takes in arguments. Yeah, multiplication is a binary operator. Because you can only multiply two things. Like if I wrote multiplication, I'd have to say something like 4 times 5. I can't just say 4 times. It wouldn't work. So all of your math operators, all your standard math operators are binary. Plus, minus, multiplication, division. Because they all take two things. You always have to do like 4 plus 5 or 3 plus 7 or 2 times 6. You can't just say times 4 and then have it figure it out. Now the exception to that is negation. Negation is a unary operator, but C++ doesn't support negation. At least out of the math ones. I mean, we have other ones too. Pretty much everything that we use is going to be a binary operator in C++. There's only going to be one ternary operator. I don't think you can override it, in fact. So I guess that's not really a big deal. There is an operator that actually takes 3 things in C++. Yeah. Any other questions on that? I'm going to delete this one. Alright, so we only have a few minutes left, so let me just do one more example really quick. And then we'll talk about actually finishing the division operator next time, because there is something I made a mistake with here. Or not made a mistake, but I haven't really finished it yet. And it's probably not obvious that that's true just because the ones that we've done so far actually work correctly. Okay, so one thing I realized that we never talked about, and I was kind of surprised wasn't on the test, was comparing classes. So really quick, I have fraction 1 and fraction 2 here. So I have another binary operator. And the compiler will actually generate, or at least it should, generate a operator definition for you, even though we haven't written it. And that operation is equal equal. So if I say fraction 1 equals fraction 2, it should allow it. Oh, C++ doesn't. Huh. Out of all the things for it not to be rigid about, actually be rigid about, I'm surprised it's this one. So it doesn't actually let me compare fraction 1 and fraction 2. Well, my example kind of goes out the window. Yeah, I would have to overload it. I didn't think I would have to overload it for it to actually generate it, though. But maybe I know why that is. I guess I was expecting it to have it anyways. Let me at least finish writing the code I would have hypothetically written really quick. So I do need to overload equal, you are right. And the reason being that I was going to make here was that, what does it mean for two fractions to be equal to each other? And the fact that the compiler, again, doesn't really know that by default. But I was going to make an exception here because usually, I say usually, most languages will actually let you compare class types without you having to do an operator overload. The reason C++ doesn't is because it has pointers. So let's change these to pointers really quick here. So this is a new fraction. And this is a new fraction. So now it should let me compare them, right? Hopefully. Else. Expected a semicolon. Oh, right there. And then now these don't work because they're pointers. Oh well. Throw that out. Okay. So now I can compare fraction 1 and fraction 2. So the first one is 4/5, the second one is 3/7. Are they going to be equal or not equal? So hopefully that one should be pretty obvious. This one should be not equal, right? So 4/5 and 3/7 are definitely not equal. You can say that pretty confidently. All right. What about if I made another one here? I called it fraction 3 and made fraction 2 and fraction 3 both 3/7. And I said fraction 3 equals fraction 2. Now are those ones going to be equal? So if I do 3/7 equals 3/7. Yes? Any other guesses or any justification? Yes? Well, let's run it and find out. Ah, it says they're not equal. Even though it's 3/7 and 3/7. Why is that? You got it. Yeah, they're different addresses. So consider, and this is, I think, maybe easier to see in C++ than it is in other languages, at least at first. They are pointers, right? So they have different addresses. And because I'm comparing pointers, it's comparing the address of fraction 2 to the address of fraction 3. So their values actually don't end up mattering. And that's why we need the overload in C++ at least. So the thing is, if you try to compare classes by default, regardless of the language, C++, C#, Java, any of that stuff, even Python I think compares the pointers, it's not going to go through and compare all of the member variables. And part of the reason is what if I had a class that had 200 member variables? That takes a really long time to compare, and you really shouldn't have that behavior by default. So it shouldn't compare fractions. So fractions are kind of simple here, but if I have something that has 200 and it has to compare and make sure that all of them are the same values, and especially if any of them have pointers to other things where it has to check the values of those things as well, then that's a really expensive operation. It takes a really long time. So you'll notice that regardless of whatever language you do, if you set fraction or like a class type equal to another class type, it won't actually check the values of the class type, but rather the pointers to the class type and match them together. So this would only work if I did something like ampersand fraction 2. Oh, I guess equals fraction 2 with a pointer. So now they're equal. So this point here is equal by definition will always check pointers. Even in other languages where you don't have access to pointers, it will secretly check the pointers that it keeps track of that you don't have access to. So something very important to consider. Any final questions on that? I guess we are at time. So if you have any questions, feel free to ask. And if not, I guess I'll see you next time. But I'll stick around for a few minutes. Is assignment... Yeah, assignment 7 is probably going to be due on the 31st. It might be later. I'm not entirely sure yet. Assignment 6, I guess we're going to do next week. I think it's still being written. I haven't received it yet, but it's on this operator overloading stuff, so I think that's why I haven't gotten it yet. So you guys basically get the week off in terms of assignments, so that's a good thing. I guess as a reward for having to deal with assignment 5, because that seemed to be kind of hard for a lot of people, which is understandable. I think that one was a bit difficult. Stop the recording.